For all those who just joined, we're going through 20 minutes per set of five today. So we're gonna do 11 through 15, and we're reconvening at 8:23, where I'm gonna go over them. Okay, so 8:23 right now, so I'm gonna start going through the problems. We got, let's see, question 11. 11 states that Abby, Bridget, and four of their classmates are seated in two rows of three. Shown. If seating positions are assigned randomly, what is the probability that Abby and Bridget are adjacent to one another? So what adjacent defines as this would be adjacent, but diagonal is not adjacent. So once again, with probability, we define it as our selected number over our total number. So what we have is how many ways in total can we arrange them? Well, when they say four other classmates, there's no distinction. So between these four, they are indistinguishable. So what indistinguishable means is if Abby and Bridget are here, this arrangement is the same no matter what because these classmates don't have distinctions, so we can't make distinctions. So what we want to look at is, and we can just call them 1, 2, 3, 4. So if 1, 2, 3, 4 are here, or 4, 2, 3, 1, those are all the same because they're indistinguishable. We can't tell the difference between their classmates. So what we want to look at is how many total arrangements are there? Well, how many arrangements are there for Abby? There are 6 choices for her to sit, and then 5 choices for Bridget. But Bridget and Abby are the same. We can assume, or we can assume they're not the same. And this question doesn't make a difference. So actually, we can assume, let's say they're not the same. So in that case, it gives us 30 ways to seat them. But we want to see how many total ways everyone can be arranged. I mean, this is our total ways. We want to see how many ways Abby and Bridget can be arranged. So let's look at the possible adjacent. We have 1, 2, 3, 4, 5, 6, 7. So there's 7 adjacent arrangements. But with each adjacent arrangement, we said Abby, Bridget, Bridget, Abby are different. So we have Abby, Bridget, or Bridget, Abby. So what that would mean is we have to multiply by 2. So we know there's 14 possible ways to arrange Abby and Bridget. And we know there's 30 in total because there's 6 choices for Abby and 5 choices for Bridget. And we don't care about the other 4. So which leaves us a 14 over 30. See, a 7/15. And that leaves your answer as C. Moving on to number 12. The clock in Siri's car, which is not accurate, gains time at a constant rate. On one day, he begins shopping. So let's do car and actual. So he knows his car clock and watch, which both say 12. So let's denote both these as 12 at first. And when he's done shopping, his watch says 12:30 and his clock says 12:35. So what do we know from this already? For every 30 minutes that pass in real time, 35 minutes pass in the car, which means if we look at a ratio here, time passes 7/6 as fast in the car as it compares to the actual. So when the car says 7, that means 7 hours have passed. Well, we know 7 hours times 60 minutes over 1 hour is 420 minutes. So if we know 420 minutes passed, but we also know there's a ratio. So 7 minutes in the car equals 6 minutes in real life. And because it passes at a constant rate, this ratio should be preserved. So 420 minutes pass in the car, X minutes pass in real life. Solving this, we get 7x equals 420 times 6. X equals 60 times 6. X equals 360. 360 minutes over 60 minutes per hour equals 6 hours. Ugh. So we get B. Six hours passed. So it's at 6 o'clock. So Layla took 5 math tests, each worth 100 points. Layla's test on each scores an integer between 0 and 100 inclusive. Layla received the same score on her first 4 tests, and she received a higher score on her last test. Her average score on the 5 tests was 82. How many values? How many values are possible for Layla's score in the last test? So what do we know? She scored X on each of the first 4 tests. We'll call her last test score Y. So what do we know the average of these? 4x plus y over 5 is equal to 82. And what else do we know? We can do 4x plus y equal to 410. So what do we know? We know that both x and y are less than or equal to 100, and they're both natural numbers. So what does this tell us? This tells us x and y both can't exceed 100. So let's start with trying to find our largest possible value for y. Well, actually, let's start with the easier one. Let's find the smallest possible value for y. So y, see, can y be 0 through 9? Y can't be 0 through 9 because if y were to be 0 through 9, 4x would be something equal to something greater than 400, and therefore x, so if x is equal to, that means x is greater than 100, which can't be true, so x cannot be 0 through 9. Y can't be 0 through 9. But if y is 10, that means x can be 100, which means this works. Now let's try to find the largest possible value for y. So we could try to see y equals 100. So we get 4x equals 310. So x is equal to 77.5. But we know that can't be true because we said that x has to be an integer. So if x can't be 77.5, let's make it, and it can't be smaller because if it was smaller, make y greater than 100. So x can be 78, which would mean, x can be 78, which would make y 98. So now that we find that our smallest and largest possible y's, we know our smallest and largest possible x's. She can score anything from 78 to 100. But y's must be multiples of 4. So when we look at it like this, we know her maximum and her minimum for each test. Knowing that, sorry, I'm sick. One moment. Okay, sorry, I'm back now. Now we know what their boundaries are. Now we have to read the last condition. How many values? She received a higher score on the last test. So we know that the y equals 98, x equals 78. And we know it's a 4-to-1 ratio. So every time we increase x by 1, y decreases by 4 because we have a multiple of 4 here. So every time x increases by 1, the total would increase by 4, so y must decrease by 4. But we also know that y is greater than x because her last test is greater than her smallest tests. So let's just start counting down. We say x is 77. X is 79, which means y would have to decrease by 4. Y decreases by 4, etc. X equals 80. Y equals 86. X equals 81. Y equals 82. X equals 82. So we see the point of equivalency is at 82, where she scores an 82 on everything. But we know that she scored higher on these, so only 4 values work for her to score higher, which means our answer is A. Okay, 14. Let n be the greatest 5-digit number whose digits have a product of 120. What is the sum of the digits of n? Well, first, let's factor 120. What is 120? It's 2 times 60, which is 2 squared, times 30, which is 2 cubed, times 15, which equals 2 cubed times 3 times 5. So our goal is to create the largest possible number. Well, we have 5 spots. We always know we can use 1, because 1 multiplied by the total is always going to be 1. So our goal is using 2 cubed times 3 times 5 to create the largest possible starting number, which is 1 digit. So we could obviously make it 5, but what else could we do? We can do 2 times 3, which is 6. Or we could do 3 cubed, which is 8. So 8 we can have as our first number, and it's not possible to make 9. So 8 would be the largest possible first number. And we want to make this as large as possible because we know everything else will be a 1. And every number starting with 8 will be greater than any other number starting with 6, 5, 3, 4, or 2, or 1. So we want to use 8 as our first number. Okay, so now we're left with 3, 5, and 1s. So we want this number to be as large as possible, which leads us to pick 5, because 5 is bigger than 3 and 1. And once again, we want this number to be as big as possible. So we pick 3, which means these have to be 1. Okay, and they're asking for what are the sum of the digits of n? Well, we have 5, 3, 8, 1, 1. It's equal to 18, so your answer is D. How did I get the first equation for question 12 or 13? Well, this one, 120. I factorized 120. So I did a prime factorization. Because you want to look at the factors. Because using these factors, you want to create the largest 1-digit number to put at the start. Because a 2-digit number, you obviously can't put at the start because it's the 2-digit number. And, well, obviously you don't want to use a 3 or a 5 by itself. So you want to make 8, because 8 will be bigger than anything leading with anything else. And for question 15, in the diagram below, a diameter of the 2 smaller circles is the radius of the larger circle. If both small circles have a combined area of 1 square unit, what is the area of the shaded region in units? I'm very bad at drawing, so ignore these circles. Okay. So I'm going to call the radius of one of these small circles R. So what do we know? Let's find the area of the small circles. The small circles are R, the big circle is big R, and we know that 2 small radii is equal to the big radii. So the 2 smaller circles combined. The area of a circle is pi r squared. So we have the area of 2 of them. We have 2 pi r squared is equal to 1. But what do they want? They want the area of the shaded region. The shaded region is the area of the big circle, which is pi big R squared, minus the area of the small circles, which we just said is 2 pi r squared. So, but we said that big R is 2r. So we get pi 2r, which is equal to big R, minus 2 pi r squared. We don't want to simplify this to 1 yet. So what do we have? We have 4 pi r squared minus 2 pi r squared. And this is equal to 2 pi r squared. So we know the area is 2 pi r squared. But what did we say that was? Right here, the sum of the two smaller circles is 1. So we know the area of the shaded region is 1. The answer is D. So if you're smart with your algebra and you look at this question, you never actually have to find out what the radii is. You're just going to express everything in terms of it, and you already know that 2 pi r squared is equal to 1. So once you complete the math, you're just left with 2 pi r squared, which you know is 1 already because they told you. So your answer would be D. Okay, so the next set is a bit trickier. So 16 through 20, this is a harder set. I'm gonna give you guys 25 minutes to do the questions and a 5-minute break, which means we will reconvene at, oh, that's a little small. So we will reconvene at 8:10. That is a crappy 10. Let's see. I'll leave 16 up for now, and about 10, 15 minutes in, I'll scroll down for so you can see the answers to 20. It's 8:40. My bad. Okay. Anyways, same idea. 9:10. Okay, let's get started on this set. Probably be our last set of the day. Starting with question 16. Professor Chang, or Chong, however you want, Chong? I don't know. I dropped out of Chinese school. Has 9 different language books lined up on a shelf. 2 Arabic, 3 German, and 4 Spanish. How many ways are there arranged in 9 books, keeping the Arabic books together, Spanish books together? So, what do we know? We have the Arabic books. Let's put them in a box. Label them Arabic. We'll have the Spanish books together. Label them Spanish. And then you just have 3 Germans. Well, we know that all the books are different. That's a key word we want to read. Different. So what do we know? They're all distinguishable. So how many ways can we order 5 distinguishable items? Well, we already know that. We already know it's 5 times 4 times 3 times 2 times 1. Because you have 5 choices for the first one, etc. But that only gets us 120. What we're missing is just because the 2 Arabic books are together doesn't mean they have to be in the same order. It could be Arabic 1, Arabic book 2, or Arabic book 2 or 1. And it's the same thing with the Spanish books. It can be 1, 2, 3, 4, 4, 3, 2, 1, dot, dot, dot. So there's 2 ways to arrange this. And I find how many ways to arrange 4. We know it's 4 times 3 times 2 times 1, which is 24. So if this times 24 times 2. And that gets you, I think, 48. So you get 5, 7, 6, 0. So this one's C. This one is not a hard one. This one you just have to pay attention that even though once you arrange these bundles in German books, you can arrange the books within each bundle. So you know there's 4 ways to arrange it, and you also have to pay attention that all the books are different. Okay, question 17. Bella begins a walk from her house to her friend Ella's house. At the same time, Ella begins to ride her bicycle towards Bella's house. Let's draw this. You get Ella and Bella. They maintain a constant speed. Ella rides 5 times as fast as Bella walks. The distance between their house is 2 miles or 10,560 feet. Bella covers 2.5 feet with each step. How many steps will Bella take by the time she meets Ella? So what do we know? We know their distance is this, and we know that Bella's pace is 1/5 of Ella. So we know Ella is equal to 5 times Bella because they start at the same time. So how far Ella moves is going to be 5 times as much as how much Bella moves. What else do we know? We know that the amount that Ella moves plus the amount that Bella moves is equal to 2 miles. Because that was clearly stated. So what do we know? That Ella travels 5 times as much as Bella. We know this because Bella walks. So if Bella walks X distance, Ella has been working for the same amount of time, but she bikes 5 times as fast. So she'd have moved 5x. So when they meet, they've both been working for the same amount of time when they meet, which means that Ella would have gone 5 times as far as Bella had gone. So knowing this, we can substitute to get 5 Bella plus Bella. Get the 6 Bella. And just by doing division here, see, you get this is 1,760. So we know that's how many feet she's walked, but they asked how many steps will Bella have walked. Well, she walked 2.5. So we want to divide. She walks 2.5 feet per step. So what does that mean? When we're completing this, we get she walks 704 steps, which means 17 is A. So the tricky part is you have to realize they're asking how many steps she walked, not how many feet she walked. So that's just a tricky reading catch at the very end. Trip up anyone. So question 18. How many positive factors does 2, 3, 2, 3, 2 have? Well, our first challenge is finding the factors of this number itself, the prime factors. But what do we know? There's a divisibility rule for 11. The divisibility rule for 11 says that if we alternate numbers and alternate numbers again, so we get 2 plus 2 plus 2 minus 3 minus 3. If this is equal to 0 or a multiple of 11, the number is divisible by 11. And we can see that through the divisibility rule of 11, the sum is 0. So we know this number is divisible by 11. If you don't know this, Google divisibility rule of 11 after this class. So we know it's divisible by 11. So let's do that. Okay, so we know it's 11 times 1, 2, 1, 2. Let's try the divisibility rule for 11 again. 2 plus 1 minus 1 minus 2, which is again 0. So we know this is also divisible by 11. So we get 11 squared times 192. Well, this is even, so we get 2 times 11 squared times 96. It's still even. 2 squared times 11 squared times 48. This is divisible by 8, so I'm just going to take out all the 2's. This is divisible by 16, so I'm going to take out the 2's to save time. So we have 2 to the 6 times 3 times 11 squared. Okay, so now we used our divisibility rules, and now we have our prime factors. 2 to the 6 times 3 times 11 squared. I'm going to write 3 to the power of 1 here. But how do we know how many positive divisors this has? Well, to do that, it's 6. You see 6 plus 1. 3, it's 1 plus 1, and 2 plus 1. So it's 7 times 2 times 3, which is equal to 42. But why does that work? I want to look at that here. So say a number has divisors 2 cubed, 3 squared times 5. We want to find the total number of factors of this. Well, a factor can either have 0, 1, 2, or 3 2's. So if I were to choose a factor of this number, I can give it either 0, 1, 2, 3. So it can either be have 0 factors of 2, 1 factor of 2, 3, 2 factors of 2, or 3 factors of 2. Okay. What else do we know? For threes, we can either have 0 factors of 3, 1 factor of 3, or 2 factors of 3. For 5, we can either have 0 factors of 5 or 1 factor of 5. So we can see that we have 4 choices for how many 2's we put in our factor. We have 3 choices for the number of 3's and 2 choices for the number of 5. So it's always 1 greater than the power. And we know that each one of these factors are unique by the fundamental theorem of arithmetic. Because it says every number has a unique prime factorization. So if the prime fact, these are all prime factors. So because each one of these has a different number of factors, each number has to be a different number, which means that they're giving us a unique number of factors by fundamental theorem of arithmetic. So we know that the number of factors for this number would be 4 times 3 times 2, which would be 24. So in our case, it was 42. So when you're thinking about it, you can think, do I want to have 0, 1, 2, 3, or 4 factors of like 2? You gotta because you're choosing how many 2's you have. And then each combination gives you a unique factor. So if you can just multiply them to find the total number of factors. That's something you're going to see a lot with AMC. They really like that question. So you want to remember that's how you count the total number of factors. You also want to remember The divisibility rule of 11. That's a very important rule. It saves you a lot of time when you alternate digits and then just subtract them at the end. If it's a multiple of 11, the number is divisible by 11. The proof isn't too difficult. If you want to try it on your own, you probably can prove it. Okay, so a sine pyramid, in a sine period, a cell gets a plus if the two signs below have the same sign, and it gets a minus if the two signs below have different signs. The diagram below illustrates a sine pyramid with 4 levels. How many possible ways are there to fill a 4 cells in the bottom row to produce a plus in the top of the pyramid? Okay, so let's look at it like this. So we immediately can tell there's 2 major cases. We know the top has to be a plus. We also know, oh, I drew these too close. Of course I did. So what else do we know? We know that for these to be a plus, the bottom two have to be the same sign. So it can either be 2 pluses or 2 minus signs. Okay. Now, what do we know for this? Let's start with this case. For these to be 2 minus signs, what can we have? Well, every group of 2 has to be different. So if this is a plus, this has to be a minus. And for these two to be different, this has to also be a plus. But this could also be a minus, this could be a plus, and this could be a minus. So there's 2 ways to arrange that. So let's draw the plus and minus one on that top arrangement. And now for down here, I'm going to draw another pyramid to represent the other possible arrangement. Okay, now we know this is a minus sign. So once again, we know that this can be a plus or minus, and this has to be a minus sign because these have to be different. Now this is a plus, so these two have to be the same. So this has to be a minus sign. But this is a minus, so this has to be a plus, so they're different. But once again, we can choose this to be a minus, plus, plus, minus. So that just gave us 2 ways to fill our pyramid. And what else do we know? Let's look at this one. If it says plus, plus, minus, plus, plus, minus, plus, we want to see how many ways we can fill this pyramid. Well, for this plus, let's just say this is a plus because this is a plus. This also has to be the same. This is a minus, so this has to be a different sign. But because this is a plus, this also has to be a minus. But once again, we can reverse it. We can have minus, minus. These two are the same. This has to be a plus, plus. So once again, we get 2 more ways to fill the pyramid. So we know when it's plus, minus, minus, there are 4 ways to fill our pyramid. And looking at the next one, we have plus, plus, which means the bottom all have to be the same. So we can either have plus, this has to be a plus, and this would have to be a plus. Or we have our alternate one, which I'll draw down here. Plus, plus, plus. They could be all minus, because these two would be the same, and these two would be the same. So for this one, for this to be a plus, this can either be a plus, and these would all have to be plus. Or we could have this as a minus, and they'd all have to be minus. Because these all have to be the same. So give us 2 more possibilities. Or for these to all be minus, they all have to be different, which means they must be alternating order. So plus minus, they're different. Minus plus, they're different. Plus minus, they're different. Or we can have minus plus, they're different. Plus minus, they're different. Minus plus, they're different. So another 2 ways. So in total, we know there's 8 ways to color a pyramid. So the answer is C. So this is definitely a much longer problem. And this problem tests your ability to count cases. But you see, if you draw them out a bit, and you don't get carried away drawing too many cases, you realize it's not very hard to list. And when you look at the answers themselves, it only goes as high as 16. 16 is manageable. You can manage to draw out 16. So from what we saw, we looked at our 2 cases, obviously. We know there's one case where they're plus or minus minus. And then you didn't even need to draw out this case, but to make it easier to visualize, we drew out the next case where it's all plus minus, plus minus plus, minus plus minus. And then we're just left to our bottom row, which made it a lot easier for us to count our cases and ensure we didn't miss any cases and we didn't double count. Okay, on to the last question. This is a geometry question. So we have our triangle ABC. So what do we know about ABC? Well, we know that AE is equal to 1 and EB would be equal to 2. Point D is on side AC such that DE and BC are parallel. So, these are parallel. And what else do we know? That we know that DE and BC are parallel. So we have, and now we have point F. Point F is on BC such that EF and AC are parallel. Okay, and we want to know the ratio of area CDEF. So CDEF and triangle ABC. So what did they tell us? Well, they told us that DE and CB are parallel. And what are they parallel about? They're parallel about the same line. So what does that tell us? It tells us that this angle and this angle have to be the same because they're parallel about the same line. This is one of the major postulates of geometry. It's the interior angle, opposite interiors. This and this would be the same. So that means this and this is the same. So what do we know? We know that angle ADE is equal to angle ACB because they're parallel. Because I'll just say as a reason is AC is parallel to EF. I mean, no, what am I saying? ED is parallel to CB. Okay, so what do we know? Now we know these angles are equal. What else do we want? Low battery. We want to see that this is equal. So what else do we know? We know that these lines are parallel. And how do we know that? Know that this angle is the same. And because this angle, let's call this angle X. This angle will be also X. So this angle will be 180 minus X. And this is 180 minus X. And because this is a straight line with X, these are once again parallel X, 180 minus X. So what does this tell us? We know that this triangle and this triangle. So for similarity, let's start with that. Angle is a way to tell if two triangles are similar. And we know that X and X are the same here. So what does this tell us? This small triangle is similar to this big triangle. And what else do we know? Well, we know both the big triangle and EFB share this angle. And what else? Once again, because these two are parallel, this is also X, following this same logic. So this is also a similar triangle. But what do we know? When the sides of a triangle have a ratio of 1 to X, the areas have a ratio of 1 to X squared. So what does this mean? This is a ratio of 1 to 3, which means that triangle ADE is 1/9 of the big triangle. And triangle EFB is 4/9 of the triangle, which means this empty space is 5/9 of the 4/9 of the total triangle. And that's what they're asking. What is the ratio of this trapezoid to the whole triangle, which is 4/9? So your answer is A. So the goal of this question was for you to recognize that these lines are parallel to their sides. I should have denoted this for you guys. And once you find that those are parallel, you can find these are similar triangles. And because you know they're similar triangles, you can find the ratio of the sides, and you know that the ratio of the sides squared is the ratio of the areas. And from that, you can find the empty area. Well, that's it for today's class. My computer is about to die, so it's pretty good timing. If you have any questions, you can just shoot me a message on my phone or just in classroom, really. And I'll get this recording up for you probably tonight. It was a good class. See you guys.